All right, let's try another example of a trig limit that is easier to evaluate using the squeeze theorem. So remember, I want to bound this function in between two other functions. So I'm going to start with that trig function, bounding it. I know that sine x is between -1 and 1 for all x values. And now remember, we're trying to create sine x divided by x. So now I can take each one of those pieces of my inequality and divide them by x without changing the value. Now, since we are focusing on as x is approaching infinity, we can assume that this is for all x greater than 0, right? We know it can't equal 0 because we'll have a vertical asymptote, but since we're approaching a positive infinity, we can just say we're only focusing on positive x values. So now I can check the limits of those outer functions. The limit as x approaches infinity of -1 over x equals 0, and the limit as x approaches infinity of +1 over x equals 0. Therefore, the limit as x approaches infinity of sine x over x must equal 0 by the squeeze theorem for all x greater than 0. So this is using that function squeezed in between the other two to prove that that limit exists.